Hey guys, let's do it. Homework 10. So it says triangle and congruence, congruent triangle, and Cpctc. This is a little bit of something I've been talking about a whole bunch, but I've never really named. So if you could write this out for me, Cpctc stands for the corresponding parts of congruent triangles are congruent. But mathematicians get sick of writing all that out, so they just kind of abbreviate that. So let's review. We know that similar triangles are the same shape, but maybe different sizes. So if this was a really small triangle and a really big one, those are the same shape. They're both triangles, and they both kind of look like equilateral triangles, but they might be different sizes. That's similar. Now, what we've been talking about is for two triangles that have corresponding angles, must be congruent, and their corresponding sides are proportional. These are proportional, but they're not the same. This is different than congruent triangles. Congruent triangles, they're exactly the same in every way. Okay, so triangles that are the same shape and the same size. So they're the same, not only are the same shape, but they're also the same size. Each triangle has 3 congruent angles, right? And 3 congruent sides. If all 6 of the corresponding parts of 2 triangles are congruent, then the triangles are congruent. So this should make common sense. If angle 1 equals angle 1, and angle 2 equals angle 2, and angle 3 equals angle 3, and side 1 equals side 1, and side 2 equals side 2, and side 3 equals side 3. Now, this is a total of 6 pieces of evidence. Now, we know from a different part in class that you don't need all 6 to know that they're twins. You only need 3 of the 6. But once you know they are twins, once you know you have the right 3 pieces of evidence, you can then conclude the rest of these are a match. Okay, so let's see what that looks like. The congruent triangles. So the way we would say this is triangle ABC is congruent to EFG, triangle EFG. If they asked us to write out the congruent angles, I would say angle A matches angle E, angle B matches angle F, and angle C matches angle G. What are the corresponding sides? Well, side AB got 1 line, side EF got 1 line. Side BC got 2 lines, side FG got 2 lines. Last, this line and this line match. So by definition, if I have 3 of these 6 pieces of evidence and they're in the right order, I know they're twins. And then once I know they're twins, I can conclude that the rest of these pieces are a match. And that's what Cpctc is. 2 triangles are congruent if and only if their corresponding parts are congruent. Corresponding parts of congruent triangles are congruent. Write a congruency statement for the 2 triangles at the right. Okay. So a congruency statement for a triangle would look like this. So let's give that a try. I'm going to name it across the first side and then the second. So ACR. So I got to go in the same pattern, across the first, then the second. So across the first, then the second. EGO. Now there's more than one possible answer. That would just be one possible answer. List all of the congruent parts if this triangle matches this triangle. Okay, so let's draw that out. So making a quick sketch, EFG is supposed to match HGF. Okay, so if that's true, then EFG, if I named them in the same order, angle E has to match angle H. So I kind of like to do it this way, EFG, so I like to list them vertically. Angle E has to match angle H. F has to match angle G. Right, and then the last one. So I list the first triangle vertically, list the second triangle vertically. See how that works out? And then this third angle has to match that third angle. But now it said list all the parts. So the triangle is made up of angles and sides. So now I'm going to do the same thing. EF has to match HG. FG has to match GF. And last but not least, run out of room, so EG has to match HF. You can put little lines above there. Okay. So last one on the front, it says this triangle, some of these I kind of worked on. Some of the classes we did this one already. This triangle is matching this triangle. So we know WX, the first and middle, has to match YZ, or ZY, first and middle. So we can say 7P plus 13 has to equal 20. Then we also know that WY, this whole side, WI, first and last, has to match that whole side, first and last. But whatever that whole side is, it looks like they cut off 5 and they left this. This whole side, they cut off 5 and left that. So it sounds like this is going to have to equal 11. Does that make sense? This whole side is 16, so this whole side has to be 16. Or this piece of this side has to be 11 since that piece is 11. So hopefully that's what you got. Beautiful. Check out the next video for the back.